Hello, welcome to my channel. My name is Ardi and we are going to solve practice problem 4.3 from Sadiku book, and the question is find V0. V0 is the voltage across this 2 ohm resistor here, this and this, and we are asked to use superposition theorem. Okay, first here is some hint. If we are using superposition, we need to turn off each independent source. So we need to turn off each independent source. And then analyze them as separate circuits. So here we have two sources, one current source and one voltage source. We need to analyze them as two circuits. So first when the current source is turned off, and the second when the voltage source is turned off. And lastly, we add the result of each of the circuits. Okay, first let's do the first step, which is turn off our first source. I want to turn off this current source first. Okay. Turning off current source, meaning that replacing it by open circuit. So we will have a circuit that this current source will become open circuit. Okay, let's draw that. I will pause the video and draw it. Okay, now I have drawn the circuit, and here is the circuit when the current source is turned off. It's replaced by open circuit here. So, and we are asked to find V0 here. V0, let's name this as V0 prime. V0 prime because it's different from this V0. Okay, now we need to find out the value of V0, and I will use some loops here. Let's name this loop 1. So in loop 1, we need to do, I think I will use the counterclockwise direction. So here, and I will start from this voltage source, and the current is flowing from negative to positive, so I will have minus 12 plus, and then this is 5 of I1, and then this is 3 of I1, and then this is 2 of I1, and that's all equal to 0, and we can move this minus 12 to the right hand side, and we can just add this. This is 8 plus 2 is 10, so I will have 10. I1 is 12, so here I will have I1 is 1.2 ampere, and what that does mean is we can find out V0 prime, and V0 prime is this I1 multiplied by the resistance here. So I will have 1.2 multiplied by 2, so I will have V0 prime, so I will have V0 prime is 2.44. Okay, that is our first step when the 5 ampere current source is turned off. So let's save this first, and we need to remember that later, and we do the second step. The second step will be turn off the 12-volt voltage source. So let's turn off the voltage source. Turning off the voltage source meaning that replace this with a short circuit. So here, turning off voltage source is meaning that it's replaced by short circuit. Okay, let's draw that. Okay, let's continue. I have drawn the circuit here. Okay, now that we have turned off this 12-volt voltage source, which is the same as replacing that with short circuit here. So this is 12 volt, this is short circuit. Okay, now we do analyze this circuit and we are asked to find V0. So let's name this V0 double prime. So we find V0 double prime using this circuit, and I think we are running out of space. Let me erase this side of the board first. So now we have this circuit here and we want to find out V0 here, and I want to use nodal analysis. So I name this as node A, I name this as node B, and yeah, that's it. So first I want to assume the current, which is going there, and I want to assume this current is going there. Okay, now what can we do here? Okay, let's see. At node B, so what can we do at node B? We are using KCL. KCL said that the sum of the current that goes in is equal to the current that goes out. So the current that goes in is only this 5 ampere from the current source, and then that will equal to the current that goes out, which is VB. VB minus VA divided by 3, or we can also going all the way to the ground, so we will have VB divided by 3 plus 2, so I will have VB divided by 5, and then we will have this current here, which is also VB divided by 5. So we multiply both sides by 5. So I will have 25 is equal to 2 VB. So VB is equal to 25 divided by 2 volt. And now we need to find out V0 double prime, which is this one, and VB is this one. So we can use what is it? Voltage divider. So V0 double prime is equal to this resistance, which is 2 divided by 2 plus 3 multiplied by VB, which is 25 over 2. So this cancel each other, and then this is 5 and this is 5. So I will have V0 double prime is equal to 5 volt. Okay, now we have the two results here. V0 prime is when the 5 ampere current source is turned off, and 5 volt is when the 12 volt voltage source is turned off. And how to find the final value of V0? We just add them. So V0 is equal to V0 prime plus V0 double prime, and V0 prime is 2.4, then V0 double prime is 5. So I will have V0 is equal to 7.4 volt. So here is our final answer for this question. So hopefully I explained it clearly, and don't forget to subscribe and like the video so I can get more videos done for you, and thank you for watching.